supervisor. So those are the things I wanted to talk about when choosing the right project. Another thing also important is about like you have to avoid vague topics, which is important. You have to think about what do you have available and the expertise of your supervisor. You can't be talking about advanced quantum computing if your supervisor is not in that field. It might be too difficult. You might not get the technical backing you need for that kind of project. Another thing is like you have to think about the feasibility of time and resource constraints. For example, second semester is when the bulk of the project goes in, but second semester is always very short. So you have to think about what can you do, how many weeks do you have left, and which project can you fully finish in due time for within the time that you have left. So also all of that should influence the right topic that you are going to choose for your final year project. Another thing that is also very, very important is like when you have a topic and your supervisor gives you a go ahead to say, I think this topic is good, you have to be very, very smart. For example, some supervisors have a way of getting you to like get very big objectives. You have to do A, B, C, D, E, F. You have to find a way in which you can clarify the objectives that you want, define smart objectives, clearly state the project boundaries. What are you going to do and what are you not going to do? Let it be clear. In fact, write it down and send it to him and pin it down to him so that along the line, won't say, I thought you are going to do A to Z. You could easily tell him that, sir, you said I should do A to B, and I've done A to B. And at that point in time, you can easily go scot-free. But if you don't define the boundaries early, what happens is that when you do A to B and your supervisor say, yeah, you're still going to Z, and it keeps expanding the project for you, and it looks like you've not done well. And at some point in time, if you feel tired and you stop putting in effort, the supervisor might just say you are not serious and you didn't finish your work, and eventually it might also affect your grades. So from the get-go, make sure you define the objectives for the work, the boundaries that you have with the project, the expected outcomes and deliverable. What does he want? Does he want you to present a simulation? Does he want you to present an hardware? What does he want to see that is going to give you 100% mark? All of that you need to know as you are interacting or thinking about your project or interacting with the lecturer. So they might not tell you explicitly, but you have to ask questions and figure out how to be able to get those insights from your supervisor. Another thing that is also important is planning, because oftentimes project goes along with other things, extracurricular activities, religious activities. So you have to plan time for your project. And for me, I think it's all about breaking the project down into proposal, design, implementation, testing, and the reports. Oftentimes, it's also good to have like a timeline that you've defined for your work. And also too, you have to set milestones for yourself. What do I plan to achieve this week? What do I plan to achieve next month? And carry your supervisor along in the process. And as much as possible, start early and avoid last minute rush. For me, I also have this experience, especially for people working on electrical engineering projects. There's always this issue of defining the project and trying to get hardware in the last minute. And once you get the hardware in the last minute, you order it from maybe China or US, and it takes maybe 2 weeks to come, and you be delayed. And your last minute, a day to your defense, you are trying to connect one board and one electronics got bumped, and you don't have something to present. All of that comes from last minute rush. So as much as possible, avoid last minute rush when you plan for your project. Working effectively with supervisors is all about scheduling regular meetings. If you are going to be meeting every Friday, have it in mind that every Friday or 10 a.m. I'm going to meet him. So if you have that scheduled already, so you know, so that at this point in time, I need to meet him, I will need to see results. So he's not calling you every time that Monday morning, where are you? Tuesday morning. No, you already have an agreement that I'll be coming every Friday to talk about my project. And every Friday, always make sure you have something to talk about, something new to show that you are making progress with your project. So you have to come prepared with progress and updates, not just stories. Nobody wants to hear stories, so you have to show commitment that you are working. And sometimes you do have bottlenecks, meaning you are trying to do something, you could not get it done. So before that Friday, maybe on Wednesday, you can tell them that, sir, I'm having issues with this, and I don't think I'll be able to make up with what I said I'm going to deliver on Friday. It might assist you along the way. So if you think that result, you won't be able to get a result on, say, Friday that you normally meet, communicate upfront and let him see a way in which he can help you out, such that by that Friday, you can still have something to show. Instead of coming on Friday to say, sir, I could not do anything, it's just like stories. So those are some of the things that you need to look at Another thing that's also important is like the feedback of the lecturer. What does he want? Is he saying you should go this direction? Is he saying you should go this direction? Is he interested in your approach, or does he want a specific approach in mind? You have to listen to the nuances of the lecturer, their body language, their feedback as you work on your project. Then also too, that is also important is you have to document all discussions and decisions. For example, if you agree to go a particular direction, document it. It's going to help you out when you are writing reports. Oftentimes, when you are writing your report, it's often going to clash with when you want to do your exams, tests, and all other things, especially towards the end of the program. You might not remember everything. So, but if you document very well, writing your report will be easier because you'll be putting all those documentation together. It can be a WhatsApp documentation, it can be a document, it can be a note. You can just put all of those things together to be able to write your report when the time comes. So all of that is going to influence your grade because they're going to read the reports. And so oftentimes it is whatever they read, they're going to grade. So you have to make sure that there is evidence of your act of your work in what the graders are going to read. So you have to make sure that as much as you are putting in a lot of work to get the results, you're also documenting it properly, well typed, well formatted, so that you can get the right mark that you deserve. Literature review strategies. Lecturers will talk to you more about this, but you have to use credible sources. You have to compare existing solutions. You have to identify research gaps. You have to use reference managers, Mendeley, Sotero, all of these things. You can go and do your research about them. Methodology development. This is up to the supervisor, and as you work together, you have to ask him which method does he want you to use. This is like where the supervisor will really have a say in what you do. Which kind of tool should you use? Should you use Python and MATLAB? You have to ask your supervisor all of this. Justifying your method. Your supervisor can say, try this, try that. And when you try that, you have to get your results and say, when we try this, we got this. When we try this, we got that. Include models, algorithm, and experimental setup. So if you try something out, be it model, be it algorithm, you have to include it in your methodology development. So then in the process of your project, you might need to do implementation and experimentation. So you have to follow structured developmental processes. You have to validate model and simulation. You have to document challenges and solutions. You have to keep backup copies of your work. This is very important. So oftentimes when you work on projects, maybe you do a simulation and it works overnight and it just went out, or your system went off, or your system crashed in the process, you don't want to start from scratch. So oftentimes, as you work on your project, always make sure you have a backup. Maybe it's on your phone. Always have a folder you keep things, or your hard drive, on your friend's phone system. Always have backup in case things happen in life. You can lose your system. Your system can get formatted. You don't want to be back to square one. And oftentimes, the conversation of the lecture and everything, you need to put all of that in a backup folder that you can use subsequently. So another thing that I want to talk about is data analysis and results. So you have to think about like, how do you intend to present your results? Do you want to use graph? Do you want to use table? Do you want to use, what do you want to use? You have to. One thing about project is like the project is not that complex, but you have to present your result like you are the next big thing that you're selling. So you have to present your result clearly using tables and figures. You have to compare results with expectation or literature. You have to discuss accuracy, limitations, and errors of your project, and you have to avoid manipulating data. What people do sometimes is like once they get values for two inputs, they just manipulate it. That is not the right way to do project. You have to make sure that all results are in the right way, and that's the way in which your results can be a good one. Report writing tips. You have to follow the departmental guidelines strictly. You have to maintain structure and flow. Use proper technical language. You have to know the technical language of your field, not just I was thinking. No. You have to put something in a way that it looks like you understand, you have a mastery of the field in which you are doing the project on. You have to proofread multiple times to make sure that you are not making grammatical errors. Avoid AI using to writing your report because it's going to be detected and it's going to belittle whatever you've done in your work. Presentation and defense. Another thing that is also important, I'm very good with presentation and defense, and I'll share some tips that I normally use, especially for good presentation. So you have to understand your project deeply. You have to prepare concise slides. You have to practice explaining to non-experts. Oftentimes, I explain to my mom about what I'm trying to do, and she asks questions, and I'm able to get the overview of the project from a non-technical standpoint, and you'll be able to know what you are missing and the assumption you are making about your project. You have to also anticipate questions from your supervisors, from your lecturers. Another thing I want to say, which is important, is like if, for example, you are presenting to a large audience and you guys are a group project, make sure that those people that don't know the project so well should be the ones to introduce the project. Once they introduce the project, they to be the one talking, and oftentimes once they talk several times and it's time for the lecturers to ask you questions, they will want people that have not talked to be the one to answer the questions. So oftentimes when they throw a technical question and you have, let's say, 3 or 4 people that are well savvy about the project, even more than those that have talked, to take the questions, the answers is going to be very good and it's going to boost the overall performance of your group presentation of the final year project. So don't make sure that because I know everything, I should be the one talking. Yes, after you've talked, oftentimes they will say the next person should talk, and if they ask the person a technical question and they cannot answer, it's going to affect your overall performance as a group. So group defense and presentation is a joint effort, and oftentimes you have to make sure that the non-technical people or not so savvy people about the project should lead the project, and those that are not so good should be the ones that are on backup to take questions and do any technical conversation that has to do with the project. Common mistakes to avoid, like basically what we'll be talking about, is poor time management, avoid plagiarism, ignoring supervisor feedback, overcomplicating the project. Oftentimes, project never ends. If you do a project today, there's going to be advancement of it tomorrow. So you don't try to make sure that it must look like the next AI. No. So oftentimes, you just have to figure out what the smallest base model that you can do to justify the topic and to make sure that you get what you need to do in the project. Once you are done with that, you can leave it. After your final project, you can always take on the project, improve it several times. So don't overcomplicate the project in a way of trying to say, I want the project to be very, very big. So ethics and academic integrity is very, very important, because final year projects, oftentimes you are going to be presenting it to academic scholars. They are going to be writing research projects on it, research papers, making publications. So you always need to cite your source. You have to avoid falsifying data. You have to respect intellectual property. If you copied somebody's work, you have to state it that I copied this somewhere, and you have to maintain professionalism. So professionalism is also very, very important when you're dealing with projects, when you're working with non-technical people, maybe in the lab, or maybe permission, maybe the school management, or maybe external bodies that you are working with to be able to achieve your project. You have to maintain professionalism with them. So in the essence of the project, so after the end of the project, you'll be able to gain technical competence, research and analytical skills, communication skills, and project management experience, because all of these things together are the lifelong lessons from handling a final year project. So in conclusion, when you are doing a project, you have to stay consistent and disciplined. You need to know when you are stuck, and you must ask for help as quick as possible. That doesn't mean you are not good, but sometimes you just don't know how to connect this thing. Ask the supervisor, find somebody in your class, go online, ask for help early, and bail yourself out as early as possible. You have to learn from your failures. What am I good at? What did I fail at, and how can I improve on it? Sometimes you go and see your supervisor and you say your manners or your approach is not good enough. You have to learn from it and improve drastically in as quick as possible so that you can finish your project in due time. And lastly, which is my favorite part of this, is like you have to figure out a way to enjoy the process. It's very tasking, it's very demanding, but you have to pick something and you have to put your mind into it, and you have to enjoy the process all through. And with all of that, if you put all that effort into your project, you are going to achieve all the aforementioned values and skills, and you are still going to enjoy the process, and you'll be able to talk more in depth about the project going forward. And I think with all of this, this is my conclusion about what you need to know about handling your final year project as an undergraduate student. Thank you, and I'll take questions and any other discussion that we might need.
Thank you so much, sir. So,
I can hear you.
Okay, so we'll be having the next section, and the question and answer will come out.
Oh, okay, no problem.
Thank you so much. So if you have questions, please write it down we'll be having our next section, and after the next section, we'll have a combined question and answer. So please just write the questions so that you can. Thank you so much.
Okay.
All right. All right. So yeah, how was that? All right. So next off, we'll be having our second speaker speak with us, and his name is Osayumame Jeffrey. He's a first class graduate of electrical electronics engineering here in Uniben. Twice, he has won the MATLAB Nigerian coding challenge. He has built and simulated real-world projects, systems, including a fuzzy logic MPP system for solar panels optimizing energy extraction using MATLAB Simulink. Also, he has designed a hybrid inverter system, which is basically simulating a DC to DC converter, MPPT controllers, battery charging, analog to digital conversion as well. Also, he has worked on projects that is basically a portable Bluetooth audio system that is designed and tested in coaches for budget-friendly DIY monitoring. Also, he worked on advanced gray wolf optimization, which is a simulation for MPPT in creating and debugging complex research models to fully functional simulation. The point about it is that he has worked on really sophisticated projects. And more than that, he has published a paper with our very own Dr. Sam, the HOD of Electrica, on the topic cognitive radio and signal processing. So at least all of the very things that we're going to be doing, whether we're going for the research circle or we are going for the project circle or the utility circle, we have like an ample of experience and talk about that. So let's quickly welcome Mr. Jeffrey Osaguwane of Touchworth. Go.
Can you guys hear me?
So can you hear it?
Abraham, can you hear me? Sorry for the. I was saying that it's better like this matter here in the first of when the 200 of each one got by out. And after that semester, something I went to back. So the time I got better and videos online. Videos online, YouTube videos, MATLAB has a resource, many resources out there like an Instagram, MATLAB or 140. So that's focus on what we target. So I'm talking about project director. you can talk about the technical aspect. Next slide. I'm sorry, my slide is a bit crowded. So, project direction and topic selection. During Mr. Ibrahim's presentation, you already explained most of this I'm going to say here. And most of them come from choosing a research topic. So when you choose a research topic, it's not something you rush into. It's not something you pick because you want to pass the project. I know it's a 6 credit course. What you want to pick because you want to pass and run away. To punch it later. Yeah, you might add in because I punch it later. But I'm here to explain why. So it's something you don't rush into because in as much as it's because this credit course, you also want to take time to actually choose a topic that benefits you now and you can use as a publication when you're applying for graduate school, for graduate education. And some common mistake that students make is that they select random topics. They are told, okay, this is in your final year, this is your project supervisor. You have your test with your project supervisor and tell you go and select topics and bring it to me. I don't know if everybody's supervisor was like that. I know mine was like that too. Go and select topics and bring it to me. Then you go online and ask Google. I'll go through a bunch of stuff and I'm like, oh, no, this is because we are not that vast knowledge. This is difficult. So let me pick something that is very easy, something that sounds easy to do, you understand? It's like I said, so you pick topics that have no clear problem statement. For example, is the role of renewable energy in sustainable engineering. And something like this, you look at the issue that it's a broad area because renewable engineering can be wind, can be PV systems, can be modular reactors, can be hydrogen generators, can be anything at all. So it's not clear. You don't even know what you have might know anything. So that thing is you don't know why there's a gap in the knowledge that they're picking the topic for. I think during my time there were people that picked topic on forgive, I know we are all not electrical students, but I'm not giving electrical examples. So it applies to everybody. Don't pick topics that are not specific. So someone I know back then when I was in school, the topic they choose was on what hazard tracking. No, what do hazard tracking is now? It's a panel that tracks the sun, can track horizontally and vertically what it does. So the issue with those kind of programs is that they don't have gap. What other gap are you trying to address? Are you trying to address energy efficiency, maximum output efficiency? Are you trying to optimize clouding effects? There's no specific reason why you are choosing it. So it's something you have to have, like, I want to focus on renewable energy. I want to focus on what's it called? Semiconductor design. But that specific is not there. What are you looking for exactly? What gap are you trying to solve? Now I know this is not a master's or PhD project, but even at that, see that small gap you're trying to solve can be different between you and scholarship. That small gap that you feel that you're trying to solve can be different between you and getting a scholarship. The other thing is working on poorly scope projects that have poor scope. They are so massive that not something you can solve with your group or on your own. For example, is designing and building a full autonomous self-driving car system. How many can we self-driving cars here? It's a big drama, right? If I tell somebody I build a self-driving car, person like, wow, this is nice, this is awesome. But can you achieve it and study and pass your exam and still deliver a very good report. No, something must suffer. That your grade is suffering. I'm not saying you cannot do it, you can do it, but something will suffer. That your final grades, this last session grade is going to suffer. Or you write a very poor report. Project will be so poor that when you are done, you'll be like, if you present to somebody like, the name is big, but context is not enough. So Mr. Ibrahim talked about being overambitious. Like, yeah, I want to be the best. I want to have the best project topic. I want to dominate. When I call my president, I want to go to back home. I could say, oh my, this guy killed this kind of year project. And so you pick something that cannot do. Something that you don't have the knowledge to it, don't have the time to do it, that focus to do it. So it's something that if you have to start it now, you abandon it later. Like, no, sir, I cannot do this anymore. Give me a new topic. And by that time has been wasted. So much time has elapsed that don't know what to do. So when you're choosing a project topic, you want to avoid overwhelming and irrelevant ideas. Like I said before, most of you will give a chance to choose. So if you are given a chance to choose, you want to pick something related to your field and then scope it down to something achievable. You're looking at something you can solve, a problem you can solve, that will not overwhelm you, that does not contain irrelevant ideas. We're trying to avoid random choice, overambitious plans, and poorly scoped projects, focusing on projects you can manage. And of course, some of these stuff will require money. Now, I know you're all students, so not all of us are financially buoyant yet. So you don't want to start to pay that before you know you're spending close to $500,000, spending close to, and the time you get a project is looking substandard. Like this one spends 500K. So you want to follow I'm following the broader process. Like I said before, identify what's important to you, identify what you're studying in school, identify areas in your studies. For electrical engineering, we are into renewable energy, microgrid, power systems, machines, we're into semiconductor materials, we're into photonics. So you want to look into things that are related to each of these aspects, then break it down into small units that you can manage the time, the budget, and your budget, and it will not overwhelm you. So another thing is I want to talk about is evaluating topic feasibility and alignment. So when you're choosing topics, there are some things you want to consider. And one of these things is be it research or design-based projects. You want to consider data accessibility. Some of you work with data already on the internet, probably data from a institutional body or a global research body. Let's say you're optimizing a 6-axis motion robotic arm, and there are already data online. You want to get those data and then compare it to your own data. It's important that you can work on projects that have data available online. And if you don't have those data online, a risk is that you would lack empirical evidence that what you are doing is actually correct. I'm currently working with Engineer Sam on Dr. Sam on projects. One of these projects, one of the requirements is to compare what you are doing with what's already existing. How is ours better? Now, I can have a result. I will have a result. But if there's no result online, how will I know my own is better? That just becomes something that's surface level. I cannot prove that my own is better. I don't have data anywhere to say, okay, I'm comparing this to this. That means one of it is not achieved, and the entire scope of the project is what? Void. Resource alignments, like I mentioned before, finance is something you want to look into. Not just finance, you want to look into, you have the tools and the software to carry out the research. Some MATLAB is a free software that has a student license, and everybody that has, every one of us here that has students email already have free student license in MATLAB, can use almost all of their resources that's under the student license to do all your project work. And if you actually check what the license cover, that it's a lot, even more than the reviews. So another thing is inability to perform, the risk of not technical research, inability to perform simulation or tests. Now, network engineers use multi-pod. So who knows what the two network engineers use? Those that are telecommunication engineers there. The two deploy it. Can't seem to remember. Huh? There's no answer. No, it's a tool for checking Wi-Fi packets, tweets Wi-Fi data as well. Wireshark, yeah, that's it. So it's allowed to read Wi-Fi data. So on that one, so MATLAB, you all know what MATLAB is now. There are other tools like mechanical engineering, people also have their own tools too for simulating hydraulic motion, moving parts of machines and the rest. MATLAB can do that too. Yeah. So time constraints on that you want to consider. You want to be able to meet up with deadline. Then supervisor expertise. Mr. Brian really emphasized on this stuff. You want to always involve your supervisor in everything you do. And you want to make sure that it's a topic that is related to their research focus. Imagine I am under a supervisor that does telecommunication or manufacturing processes and I'm doing something else. They cannot relate to them. They will not even accept that topic because they don't know what it's about. So you want to always do something that it's interest, it serves both of you. The supervisor can give you its expertise because they have done research more than you. Yes, like him. So they have done years of research. They have vast knowledge and vast expertise. Then originality is another thing you want to consider. Plagiarism, this plagiarism comes in. Always make sure that what you are doing is original. Do not plagiarize anybody's work. It's to be flagged, not be accepted. So aligning topic choices. First thing you want to do is check available time. Picking a topic, check time available. Supervisors, presentation, they are available. So I will not dwell too much on this, like I said before, because Mr. Abraham have done just all this part. Yeah, so leveraging existing work. Most of you be doing research-based projects, and that's the fact because not all of us here have the funds to do a design-based project. So those of you that have it, if you are doing a design-based project, most of you work in groups, style and share the responsibility. So even at that, the best friend is going to be Google Scholar. The best friend will be Google Scholar. You can find research on any topic you want. You can find existing research, no matter what you're looking for, it's on Google Scholar. The professor, either in our country or outside, has done similar research. Nothing you ever, like no research you ever do that will be new. No one has done it before. Not like done it before, but one has touched that research area before. MATLAB 5 So those of us that are doing simulation, there is this learning resource that MATLAB provides. It's managed, it's not how GitHub is now. I mean, someone does the project and makes open so that other people can use it, right? That's how Fine Exchange is. I do a project, then I share it with everybody. Let's assume that Sean, right? Mr. Sean wants to do a project, but he needs a part of my project to do his own. Comes to the Fine Exchange, assess my profile, takes what he needs and use it in his report and his project. But once it's going to reference that my work is there. Because if it does not, it's going to be flagged with plagiarism. Because remember, it's checking the internet if what you have done. If someone has similar work, so they see my work anywhere and not cite it or reference it. Another thing is YouTube. We all know YouTube. Right from 100 level, I'm using YouTube. All our courses are using YouTube. Anything you don't understand, YouTube. Anything you want to, assignments you want to solve but you don't understand, YouTube. So YouTube is always going to be your friend in your projects. Always going to be your friend. Yeah, now to the main parts. The part I'm excited to talk about is called technical execution of your project. So I know I'm using electrical a lot, that's because it's department I graduated from, and I know more about that department compared to other departments. So probably anybody from that department, apart from electrical, can tell me like any research ideas they've had, or they have, or they have seen. I can talk about it when we are doing this part of it. Any other department, any research at all. I know you guys are from production. Please, one topic, one research topic. Solar hybrid. Which department? Why does it sound like an electrical? Okay, yeah. So using wind turbine and solar panel, right? I'll call it an hybrid microgrid that allowed. So an hybrid microgrid, you're having renewable energy. In this case, you have the wind turbine, you have the solar. There's a project I did last year. It's an hybrid microgrid that had a wind turbine, solar, backup battery, diesel generator, and a modular reactor. So in those situations, most likely you might not be asked to build a wind turbine or solar panel because it costs you. You cannot even buy a wind turbine, it's a cost. So most likely it's going to be simulation based. And one, two, not the only two, but one, two you can use is MATLAB. It has been designed that it's like Mr. Sean said, it's STEM software. It's designed for anything STEM. Engineering, math, structural, tech, anything at all can be done with it. Even chemical reaction for chemical engineers here can do chemical reaction with it. I'm not missing chemical shire, you're writing for more. So MATLAB, it's a very powerful tool. And it's not just for students. Professionals use it. Industrial giants use it. And it enables you to transform your concept into professional simulation. Can help you validate data or ideas. And understanding become into practical implementation. Now, looking at that wind turbine and solar panel, let's assume, for example, that we want to optimize the system, right? Now, if we go online, we'll see, check the Google Scholar, we'll see research topics on research work on wind turbine and solar system, we can say, okay, we want to optimize our so that the wind turbine is smaller in size, like smaller blade size, and it output the most, like this acts, it maximum output all the time. And when it pays to that, immediately it notices that the output is dropping, the solar panel starts to give its own energy. If it's daytime, it's nighttime, you can say backup give my own energy. So having that in mind, that idea in mind, we can't just draw on paper and say this is this, because we know you come out with combine pitch angle, Mian angle, output of a PV system, diode characteristics, output characteristics, power characteristics. I don't just say, okay, I've calculated everything, it's working. No. I can bring the formula to myself and say, sir, see for my black. Okay, so where's your result? How do I know that what you are doing is an improvement to this research or add knowledge to this field? All you have is formula. Okay, let's now want to go and buy the part and test them. What if it fails? Grab on that part and test it. What if that one fails? So you know you are buying parts to test just a simple that you can easily just what? Simulate. Like can you just what? Simulate. And that's where simulation comes in. You can simulate almost everything. You can simulate almost anything. Okay, so importance of simulation validation before hardware. Simulation allows you to totally validate your design before you design the actual hardware. Well, of course, I've heard about it that allows us to design electronic system, right? You test everything, see the resistor burns out, see the your code is working on the real before you design. That simulation helps us to do. You validate your design, check for errors, forward, you deploy in hardware. Now, MATLAB environment allows us to customize our settings, allows us to feel at home when we're designing simulations. Design it, you have this freedom to put what you want here, design shortcut, everything that will help you make a simulation process as easy as possible. You have help, there are apps on MATLAB that allows you to fast track your design and simulation. No. Okay, so modeling, yeah, realistically. We've all seen electric vehicles, right? Maybe not in real life, maybe in real life too. We've all seen electric vehicles, right? Now, most of these designs are done using simulation for the actually deployed. Another thing you should notice, we've heard about self-driving robots that can map out the environment and then figure out what they're going to, right? Now, those designs were first simulated. Even if it sounds crazy, you can simulate them first. We have rocks, we have, what's the name of this software? I remember, there's a software that allows you to simulate, you design an actual robot. You attach all the components to it. Then you watch as it moves, learning the algorithm, adjusting system parameters, and adjusting every other thing. So common mistakes when it comes to simulation is overlooking assumptions. I want to also remember that even as we are simulating, well, there are always assumptions in simulation. And one assumption is that you're assuming that it's most of the time it's an ideal environment. So whatever you are doing, remember that assumptions are made. So even at that, that assumption can lead to inaccurate simulation results. So when you do this in real life, easiest case is what? Ideal environment. Yes, is what? Ideal environment. Then another thing you want to look at is knowing documentation. When you are writing your project, as you are designing your simulation, you should also be documenting the steps. Always write out what you did to get these results, because it will be your chapter 3 methodology. It's what it's your chapter 3, chapter 4. The only two parts that concern supervisor, honestly speaking. That chapter 2 is just theory. They want to see how you did it and what you got. So always document your approach. Inadequate testing. Remember, simulation. If your project is going to stay in simulation audit throughout the entire project, you don't have to test too much. If you are going to design hardware, test for every possible case scenario, you're going to operate that hardware. Because if it works in your simulation and fails in real life, something that you overlooked, assumption, what made it work? Okay. Yeah, like I was saying, MATLAB is something, and simulation is something you can use anywhere. Anywhere, it's almost done. Almost done. Something you can use anywhere. So, in digital signal processing, I can use it. In sound system, I want to check how my voice is sound in an auditorium. I can record my voice, get the model of an MCO, impose them together and see how it will sound. I can fast Fourier transform, convert my voice into digital signals, put them in the microcontroller embedded system. When I say a word, it picks it up, it tests my sound, they can unlock your door, those smart homes. I can do that with MATLAB. Artificial intelligence, you can design models and design any model at all. I'm not saying ChatGPT, I'm not saying, but you can design models that runs on those larger models with MATLAB. Power systems, electrical engineers, the favorite part is going to be Cityscape Electrical. Throughout your entire design, what you're going to use. Mechanical engineers, Cityscape Mechanical too, going to be your friend. Cityscape Mechanical, Cityscape Fluid, and multi-bodies will be your friend. Robotics too, yes, there's a robotics library on, there's my robotics library on, robotic library on MATLAB, similarly. You can, now you connect your laptop to this projector, right? You can actually connect your laptop to your design, the robotics design, if you have the hardware I want to test. Something called hardware in the loop. You don't test hardware to your design pure simulation. You can use MATLAB for it to do robotic library. You can design 3D robotic arms and design 3D robotic moving parts. You can write your code and see how it moves. You can optimize your code, see how it moves. You can design your entire robots in MATLAB. Your entire robots, you don't even have to have a hardware. Then MATLAB has something called code. Code what? No. But let's call it's a code something that converts your entire MATLAB code into C, C++, or Python code. So everything you've done, all your design you've done, all your optimization, to compile it, all you have to do is now what? Upload to the system. Okay, so that's so like I said before, everything you do, every paper you reference, every file you review, every code you borrow from File Exchange, always cite them, always reference them. If not, will be flagged for plagiarism. And something we want to avoid.
But both of want them to turn on slide, but like talking to us, we just want to hear what exactly it is, because I know the majority of us came here, and that's one of the kinds of questions that we want answered. And it's the question of, in your experience, what does a good final year project actually look like? Beyond just what we know that a final year project is. So, Mr. Ibrahim, can you hear me?
Yes, I can hear you. I can hear you. So, to think about it, when I look at a good final year project, a good final year project is something that takes you to the next level of your knowledge. So what does that mean? What that means is like wherever you are, let's say you are in communication or you are in control engineering, for example, a good final year project is a project that allows you to put together all the theories you've learned and you can practically implement some of those things. I can say, I think I know this from this project and I'm able to achieve this from this project. And a good final year project is a project that can be a stepping stone into taking your career to the next level. So imagine a project that is on your CV and they can ask you questions and it can get you a job, can get you opportunities. You can use it to present yourself and showcase that you truly have a BSc and you understand the fundamentals of what you've studied. So for me, a good BSc is a project that you truly understand, that you can present, that you can defend, that you can further on because you truly did your due diligence of understanding the project and allowing your supervisor to supervise you on the project. So that's what a good project is. A good final year project is. Whatever that topic means to you is a good final year project for you.
Thank you so much, sir. So you have anything to add to it?
It's something that helps you grow. Something that helps you marry what you've learned in 5 years with what is happening outside, what the industry needs. Should be something that when you come out to speak, you're not sounding like someone that read to pass an exam. Someone that's educated and knows what he or she is saying. If your project does not solve the problem or does not address anything, you will not know anything. That's the truth. You just did it and you passed and you left. You don't grow in career. You don't grow in research. You just went through school. School did not go through.
Thank you so much, sir. Please can we put our hands together? It is amazing and it's important that we think about our final year project beyond what we have as a 6 credit load course that we should get an A on. Of course, trying to get an A on it, it's very, very important and all that. But for us, we should try to raise the bar to something that can help create more opportunities for us. So moving on to the next question, and I think quite similar to the one we just had.
is now say we want to go on and we know how a good final year project should look like. The question is, well, that sets up some kind of ambition already. And so how do you now balance the ambition, which wants to make you go really higher on what you can do? Say, for example, you want to build a spaceship that runs on water as well. How do you balance that between realism, given the time that you have, given that you're also a student and the project is not the only thing that you're working on? How do you balance that? So please, can we give your answer to that, Mr. Ibrahim, sir? Yeah, go ahead, sir.
Okay. In my presentation, I think I emphasized that there's this saying that if you fail to plan, you're already planning to fail. And before you start your project, you need to have a concrete plan and a realistic plan. And one of the things you need to look at is to how much time do you have at your disposal? Because sometimes you might not just have time, you might have other extra things that you are doing. So you have to also ask yourself, this project, how much of time do I need to be able to do a good job on this project? So realistically, if you are trying to do something that is very, very hard and you don't have much time for it, it means that you need to find a way to make it to work. Either you tell your supervisor or you bring down the scope. So in essence, what I'm saying is that if you have a lot of things going on, you have to do a project that is going to align to how much time you have to dedicate to your project. Another thing that is also important is like you need to plan your time very well and you need to leverage existing work. For example, in work these days, you stand on the shoulders of giants. You ask what have been done before. You don't need to reinvent the wheel. You need to build on existing modules so that you can easily get to the crux of the problem you are trying to solve. So all of these things, planning appropriately, standing on existing work, understanding the amount of time you have, and picking the right project that can allow you to be able to deliver in due time. All of that is recipes that you can use to be able to tackle a challenge like this.
Thank you so much, sir. Sir, you have anything to say? Second semester is very short. First semester is second semester is very, very short. Before you jump into that big idea, that's ambitious project topic, you want to ask yourself, can I achieve this with timeline I have and still study and still balance, let's not call it work life, let's call it school life, school life balance, because you will get overwhelmed. You will. So planning is everything. You should plan. And I don't think the project has to be ambitious to have impact on the community. It doesn't. It doesn't have to address, cannot solve what problem. You have to solve what problem with your project. You have to solve a unit, just something small. Professors, they have publications. No one, because they cannot solve what problem. No matter how smart they are. They have knowledge they keep building on. So you don't just solve, let them to solve, start to solve this thing so big, no, it's overwhelming. Even when you have a team, because that's when you realize that some members of your team have to focus on one level of team, and they have to make sure that that one is very strong. And for it, carrying full projects on your back. So you should plan, don't make your projects. All right, solid. Thank you so much. I'll just reiterate on the points that I think the particular quote that Mr. Ibrahim mentioned, which is by Sir Newton, if I have seen further, it is by standing on the shoulders of giants. So the point is, a lot of us think that we have to start from scratch and do one crazy stuff. Well,
if Isaac Newton are not the amazing things that he did, he also acknowledged that he's doing amazing things because he stands on the shoulders of giants, which basically means those before him. That's something for us. That would mean that we should just work on specific problems, build on other people's solutions, and make things better. Thank you so much, sir, for the answer. All right, so quickly, next. Okay, now, sort of like seeing in the same line of thought as per this project execution and realism and doing things that you're going to be able to finish and planning. Now we'll move into it a bit to thinking about how you plan. And the question here is, when you're stuck between multiple possible approaches, because you're planning and you see different things come up, how do you decide what is good enough to move forward? That's the first question. And second question is, more like on the opposite side of that, what are the most common execution mistakes that cause students to lose weeks unnecessarily? Because it's really possible to spend an entire week on something that you probably should not have even spent time on. So the first question is, what do you do when you have possible approaches to follow to get to an answer? And also, how do you, what are the most common mistakes that people make that make them to lose week? We have Mr. Jeffrey go first on this question.
So I would say the first mistake, the first and biggest mistake would be to do your projects without the supervisor. And there are now of that project. You don't have it to do. This time I carry them again. The idea of there being a supervisor is to supervise your projects. So if I've written chapter 1, chapter 2, chapter 3, and the supervisor is not aware of it, I'm not doing a project. He does not know if I'm doing a project. Okay, when I'm done, do I carry everything to him? Sir, finish that project. Do you think he's going to accept it? Because he had not supervised anything. He will send you back. That most times they will not even look at it. I not myself, someone that adds an encounter with that supervisor. The lady did not start her project on time. And the supervisor was asking her, where is your project? So she kept giving excuses. So she had a week left to our presentation. I had to rush the whole thing. It was the night, I think the morning to the next presentation that she gave supervisor the work. She said she's not taking it. And she's not taking that project because she don't know what's inside the project. Do you want to make a fool of her? Because imagine I'm presenting something and other professors are sitting down and like, this is what you supervise? This person is saying nonsense. It's to be ashamed to her. So that's not carrying your supervisor along. So already a major setback for your project. That's another question, another one attached to it.
Second question that was one. You answered the second question. The first question was, when you have multiple approaches to the project you're working on, how do you decide which one is good enough to move forward with?
So that's where the expertise of your supervisor comes in. They know, they understand the topic even more than you. Every time you go through Mr. Ibrahim's slide, he breaks it down into steps. Every time you go through a step, let them know. Let them be aware. It's only them, by them being aware, they can tell you that, okay, you are going beyond the scope of this project. No, this thing you just written does not hit the nail on its head. Go and add this or remove this or refer to these materials. Most supervisors go as far as sourcing materials for you, yes, just to make sure that you give the best. So always this centered around the supervisor, carry them along, seek that.
All right. So, do you have anything to add to Peter? Sorry, Brian.
Yes, I do. I do. So something comes to mind. So the first question was about like when you have multiple approach, which one should you go for? So there are two ways. You can talk to your supervisor about it and let him do the job. But sometimes, let's say you are in the middle of the night and you have two approach to go. So there's this principle we use in machine learning and AI. It's called Occam's razor. So it says that whenever you have two things to decide, try to pick the one with lesser level of complexity. So even if you are able to achieve it, you can try the one of higher complexity. So let's say I want to do something and this one is going to take me a day to achieve, and that one is going to take me a week to achieve. Do the one of that a day to achieve if you need to make a decision on which approach to go to. So pick the one of lesser complexity and get the results. If the result is not good enough, then you can now go ahead to do the one of higher level of complexity. So that would be my approach. Let's say you are not able to get feedback from your lecturer in due time, or you need to make a quick decision about which approach to go to and you are stuck. So that will be my response to the first question. The second question sometimes is like, from my own practical experience, project delay sometimes because of lack of redundancy. So let's say, for example, you are working on a robotic project and you've been working on this project for like 8 weeks. And one day something just happened. Your microcontroller just got burnt. And this thing you ordered for it from China. So it means like, even if you have the money now and you order it to take the next 2 weeks. So for the next 2 weeks, you are basically waiting for microcontroller. And your supervisor will say, what happened? You've not come to see me. And you say, you're well. So sometimes in planning for project, critical elements of the project that are very, very far off are very, very important. Try to see, if possible, I'm not saying compulsorily, if possible, you can get them in redundant. Get 2 versions of microcontroller. Keep one for yourself. Something might happen a day to the defense and something funny might happen. If you always have a spare, you can always use it to buy a way to buy time, or talk to somebody else that might have a spare so that you can easily get on board. But from my own experience, especially for hardware-based projects, last minute mishap, due to pressure and everything, can cause delay and you just be stuck for no reason. So one of the best ways is like, so you are planning to get your components for critical elements of your project, try to see if you can get backup or ways in which you can work around them in case they malfunction. So those will be my ways, my approach to handling those 2 questions. The first one is Occam's razor. Try to go with one with lesser complexity if you are not able to get in touch with your supervisor to decide for you. And the other one will be try to have backup for things that can really be a quick point of failure to your project and that can delay you for a long period of time.
Thank you so much, sir. That was amazing. Please, can we put our hands together? All right. Again, if you have questions, you can please pass it here. Just signify and pass it in. All right. So thank you so much, sir. Once again, the answers were amazing. I believe we are writing. Okay. The next question is as regards simulation analysis and tools. Now, I believe this has been talked about, but yet again, we just want to leave with something at least from you guys. When is simulation essential, and when is it just nice to have? And is it in every project that we would have to simulate? When should we simulate? When should we just add dates? And then the second question, the question is, so where exactly does simulation analysis and tools like MATLAB fit into a strong final year project workflow? So the first question is simulation essential? When do we need it? When is it nice to have? When do we just push it away? And then the next question is, for where exactly does tools like MATLAB, when we are having to simulate and analyze, where should they fit in? How do they fit in into a strong final year project? Sir Ibrahim, you can go ahead first.
Okay. So when it comes to simulation, for me, I think like as someone from this part of the world, simulation is very essential. Why? Because simulation can save you costs. So for example, if you are doing any project that has to do with hardware, try to see if you can simulate it first. simulation allows you to be able to know if it is worth committing financial resources to. So for me, at the get-go, if you can get the simulation working, that's a good step. You already know that at least you have something going. So for me, at the beginning of your project, if you can work on the simulation of critical part of it, can be maybe a smaller part of the project and get it to work, that's a good thing. So simulation is very important because simulation allows you to be able to tweak the parameters without buying parameters and figuring things out after later. So for example, if you've done the simulation, you already know for this part I need 1K resistor, for this part I need 10 ohm resistor. You already know exactly what you need to get. So but if you've done the hardware project and you're trying to simulate later, it's like you've done try and error, then you now want to do the simulation later. So it doesn't work that way. So for me, I think simulation comes in trying to bring the concept to life to see what the range of parameters can work for you before you eventually go into final, maybe physical implementation of the project. That's one. Number two is the fact that we live in a system whereby lecturers find it hard to believe that the work is your own. Oftentimes you be like, hope you didn't go and copy it from AI like this. So sometimes you need a simulation to really make them to see that you really understand the project. When you show me a MATLAB simulation and I can see some things, I already know AI models cannot give you this level of detail. So it makes them to trust in what you are trying to do. So for me, simulation helps in your defense. If you have a good simulation, even if they don't understand what you are doing, they can see the high level overview of the simulation, they can see the graphs, and they can easily flow. So with the simulation, you have something to defend the work against other lecturers that don't know the in and out of your work. So simulation is good for defense. If you are going for defense and you have your simulation on point, there is almost no question that they want to ask you that you cannot provide evidence beyond just your word of mouth to be able to show that this thing is actually working. So that's what I would say about simulation and when you need simulation. I don't know if I answered all the questions.
Yes, sir, you did. Thank you so much, sir. Sir, maybe like 30 seconds to answer the question.
Simulation is essential. When you are doing research for line build, it doesn't have to be MATLAB. It can be Proteus. It doesn't have to be Proteus. It can be Wireshark. It doesn't have to be Wireshark. It can be anything. The important thing is that we test the idea, we test for its functionality, test if it's possible for it to work. Thus, you have tested its capability before you actually design the hardware. If you're not designing hardware, you're already getting results. You can get results from simulation. You cannot carry out a project without simulation, unless you are reviewing or analyzing papers, which of course you guys will not do. So it's something you cannot do without. It does not have to be MATLAB, like I said. It can be Proteus, can be Action Designer, can be Wireshark, can be PVCs, can be ETAP, can be Power Factory, can be anything at all. The most important idea is to always, it gives you the ability to test your design, validate all factors that might affect your design before you actually go ahead to build the hardware or send out the PCB for manufacturer, take the PCB or prototype the design. So simulation, it's something you cannot do without, if I'm going to say. Then when you need it, you always need it. You always need it. Maybe not in bad models, maybe it's not going to be a major part of your work, but it's going to be there. It's going to be essential to prove that you did the project. AI cannot do simulation where you think it can. It cannot. It can generate code, yes. Can it do simulation? You cannot design simulation for you. Cannot design simulation files for you. So that's having that file alone is evidence that you did the work. Being able to explain what you've done is evidence that you did the work. Because to prove that you understand theory, you understand the practical, you understand the project, you understand the scope of the project, and you're able to achieve the aim and objective of the project.
Thank you so much, sir. Thank you so much. So Mr. Ibrahim will be leaving soon, so we quickly want to take this last set of questions. And all right, so this is more MATLAB focused questions. Now, what opportunities does MATLAB open for final year students beyond just completing a final year project? And second is, can you briefly clarify MATLAB licensing for students and how they make the most and how they can make the most out of it? So the question is for you, Mr. Ibrahim.
Okay, good. So now I'm speaking like an ambassador now. So the good thing about MATLAB is that it has a lot of tools that students can leverage for their final year projects. But beyond final year projects, you can also use some of these tools when you work for industries. For example, big companies like energy-driven companies, like vehicle producing companies, they use MATLAB to simulate their processes. And they are basically looking for people that can do simulations just to be able to test processes for them. Let me give you an example. We have Dangote Refinery in Nigeria, and it costs a lot of billions of naira. Just imagine that you want to do something in that particular establishment as an engineer. They will tell you that, please, can we see the simulation of what you want to do? Because we can't just allow you to go and connect anything and go and affect the system that is there. So simulation allows you to be in when the stakes are high and the establishment is very, very big. Simulation allows them to make decision beforehand. You give something to your supervisors before they can allow you to go and make changes within their systems. So that's one thing. So for MathWorks as an organization, they are supporting university students, they are supporting startups, they are also supporting companies that are also using and leveraging MATLAB. So if you follow mathworks.com, you are going to be able to see some of the tools that are available that students can leverage. And just to speak on the license, the way the license works is that there are different forms of license. There is the individual license, there is the institution license, which UNILAG has. There is also startup license, and there might be maybe organizational license per se. So which is supposed to startup license. So depending on which one you can leverage on, if you're in a school that they subscribe to the institutional license, which is like, I think it's around $300 if I'm right. So you can benefit from that because you are still a student of the school and you can leverage on that. So you can leverage the institutional license to work. If you are attached to an organization like a big empire that they have license for MATLAB, you can also key into that. And if you have a lot of personal work, more modeling and simulation, you can also go in for the individual license. Although I must say that the licenses for the individual licenses are a little bit expensive, but I still feel like as a student, you can leverage the institutional license to do most of what you want to do. So, and also there are other forms of online which are cracked version, which I don't encourage people to use. But the point is that sometimes you might need to start off with some of that before you get to work for big organizations that can give you the license version for you to use. So don't just say because you don't have license, because of that, you're not going to learn MATLAB. If you have any access to MATLAB, whether cracked or not cracked, try to use it to upskill yourself. And when you get up to a point where you really want to present world-class work, you will be forced to go and get a licensed version. But at that point in time, you already have the knowledge and the skill of MATLAB in you to be able to deliver. So what is important is to find MATLAB that you can use online and get very good at modeling and simulating with MATLAB. For the license, you have to find a way to attach yourself to existing license or any license that you can find. That will be the best way for you to make sure that at least you have the proficiency in MATLAB, at least barest minimum. So you are not restricted by the license, but it's always good to use licensed software, especially when you are presenting to the international community.
Okay, thank you so much, sir. There's a question for you on what the limitations of using the MATLAB software are. I don't know. What the limitations of using MATLAB software? What are the limitations?
Okay, so for me, for my interaction with people in industry, the limitation can be in terms of like developing something that has to do with other existing systems. So, for example, if you build systems around like Python right now, it might be easier for you to integrate with other software stacks like AI models and the likes. But with MATLAB, you have to compile, you have to do your work, and you have to compile into another language and take it into other models. So, outside integration with MATLAB might be a little bit challenging. You have to be intentional about which platform are you taking your results to and you are integrating them to. Another thing that's also important is like, for example, there is hardware in the loop process. So, for example, I spoke with engineers from researchers from Florida State University, and they are working on one big machine, but they could not use MATLAB because the time response that they need is they need something that is close to real time. So when the model runs the simulation, the time must be very, 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 very short. So sometimes when you depend on your simulation to get results, and you want to feed it into other systems that depend on the simulation, the time might be lagging. So sometimes those are limitations with MATLAB for now, and there are still ways in which the optimizations can still be done, but might not be the perfect result that you need. So, but unless you are working in those extreme cases, whereby, for example, latency is a very big issue for you, you need a much faster response. Maybe you are working in more like a near real-time system. MATLAB tends to be a little bit slower compared to other models that you can leverage on. So those are the limitations I can see for now. But within MATLAB, within MathWorks as an organization that is in charge of MATLAB, they're also working to improve the software. So for now, these are the limitations as of today as it is, but we might have optimized processes that can take away those limitations in the nearest future. But those limitations, I don't think they really pertain to us right now, especially in Nigeria and the scope of the work that we do. But that's for more advanced work and people that are working in a much faster, in a system that requires a little to no delay at all.
Solid. Thank you so much, sir. So I think the point about this was, well, as far as our final year project is concerned, and we are at the University of Benin, and there is no limitations to using MATLAB as far as it's concerned, and I believe every other part has been sorted out. Okay, sir. I think this question again is also one that we really wanted to make sure we get answers to. Looking back, what's one thing you wish you understood earlier, or rather, something you understood earlier that really made your graduate level experience, your graduate level project really amazing? I'll go over the question again. Looking back, what is one thing you wish you understood earlier that really helped you while working on your undergraduate level project, or you did not? It's a two-way question. You got it and you were like, oh wow, it really helps. Or you did not get it and you're like, oh, I wish I got this. It's made my work easier, just so we can learn from both experiences.
Okay, let me answer the question. So mine is a bit funny. So in my final year back in OAU, because I did my final year in OAU, Obafemi Awolowo University. So during that time, I was into so many things. I was representing the school in competition, so many things. So, and I was also working for another startup. So I had too many things going on. So in the process, my project was not the problem, but I needed to finish the project in due time, because towards the end of the semester, I have other commitment that I need to do. So I went to see my supervisor. I told him, sir, these are the objectives. These are the things I want to do with the project. Is it okay for me to do the project and everything? He said, fine. He's like, yeah, you can do it. Yeah, these are the things you need to do and everything. So my mind then was like, you know what, Ibrahim, by 7th week, I'll be done with my project so I can focus on other things. So I'm telling you this story. This is the first time I'm sharing this story publicly. So I went to see him. He said, no problem. He never believed that I can even finish the project in 6 or 7 weeks. So I worked tirelessly, although I have a lot of background experience with all of these things. So I delivered the project in 6th week or 7th week. So I went to see him. So my mind was like, I'll just finish this project and everything. I'll just put it on that corner and I can go and focus on other things. I'm done with my project. I was very happy. So I went to see him. So the man looked at me. I was presenting the project to him. Everything is working. I even did my slide just to tell you, like, I was ready. So he looked at me and it's like, okay, this is cool, this is cool, this is cool, this is good. And he said, Ibrahim, if it's another student of mine that came to present this thing, I'll go to your report and I'll write A for the student. But this is you. This is the 6th week. And look at what you've done. There's a lot that we can still achieve. So I won't allow you to go and rest. So I'm going to expand this project for you because I know you can deliver. So he expanded the project for me. So that's the reality. So sometimes when you deliver what you need to deliver and you still have a lot of time, I don't think supervisors sometimes will allow you to go and rest. So I didn't know that before. I thought if I do what I need to do, I can take the time off to go and play and do other things. But it didn't happen for me like that. So I got to do like twice the work that I initially planned to do because of that scenario. So I didn't know about that before. So sometimes if you have other things commitment, you have to scale that along with the time of the project. Or else if you deliver in due time, supervisors most likely will expand your work for you. And it's going to clash with other things that you really save time for. Hello?
Yes, we can hear you, sir. That was awesome.
So that's my experience.
Not be fast.
Sometimes if you are too fast, you just like this student is a very good student. He has done a lot of work. The supervisor will be like, this student can still do more work. So you most likely will give you more work.
Awesome. All right. Thank you so much, sir. Really appreciate the time spent. So we have here a senior lecturer of control systems engineering,
Okay.
Dr. Edosa Osa, and we want to welcome him at the video.
All right, good afternoon, everyone. So nice to be in your midst. I think this is a very wonderful presence. I want to appreciate everybody that has been here, the speakers, the organizers, and all the students that are here to benefit from numerous great minds like yourself, Mr. Ibrahim, Mr. Omokari, Mr. Romosele, and indeed everyone that has tried to make this day possible. Well, on their behalf as a lecturer in this institution, I want to thank you all for the knowledge you have divulged here today. You never can know what you have done here today. It will go a long way to shaping the future of these young minds you have tried to impact. And on behalf of the organizers and the university at large, I want to say a big thank you to all of you. And we hope we will have more times like this. Probably see you in person, either here or over there where you are. Please, we hope you make yourselves available. Once again, good afternoon to you all, and thank you for a wonderful time out.
Thank you so much, sir.
Thank you very much, sir.
Time spent here. We know that you're a very, very busy man. He's also currently, at least for the ones that we are well, he's currently having a MATLAB and Simulink-like training over there at the University of Lagos. So his schedule also is quite tight, and we really, really do appreciate your time spent here, sir. Thank you so much. We'll be reaching out more often. Thank you for taking the time. All over the process, he has been pulling and encouraging us and making sure that this came to reality. Thank you so much, sir. We do really appreciate your time. Thank you for joining.
Thank you.
Okay. So we would, since we have to also, yeah, thanks. We have to also, okay. So we'll just take a few questions and then we'll be done. And these questions are mostly going to be, since we have Mr. Jeffrey here, I'm mostly going to be his experience on the, going to be his experience, at least based on his here with us, and that's what we are going to be sharing. So, right, I'll just go over a couple questions and be very fast. Okay, so now we talked about the fact that we kind of like have to look at what we have academically, the workload and everything, and then plan around that. So I think the other thing is this: as we go about our final year projects, these tools that we're going to be using, mostly MATLAB, we might be using other software like Pro Tools and the different ones for our specific needs. Now, there might be this push to want to go and take a course on it. So my question is, given that we don't necessarily have the ample of time to delve into the nitty-gritty of why something works and the way it works and how it's supposed to work, and what would you say realistically, Mr. Jeffrey, is the way to go about this, given timeline that we have?
I should say ramp process. Because there's no how you want to do something you don't understand or you don't know. So even if the time is very short, take an ramp course. It's very important because that is going to be the only way you understand what the interface is, how to use each of the blocks. If not, I can explain the whole thing to you and you still not understand. I can tell you, use this solver and be like, why am I using this solver? Or what does this solver do? Your design can be so perfect, but because you're using the wrong solver or the wrong time or the wrong tolerance error, everything is not working. And you would not know because you have not taken the course on what you're on the software you're using or the simulation software you're using. So no matter how tight it is, take an on-ramp courses are very short courses. It's just breeze through everything you need to know without going into too much detail. To take those courses. If not, you will not achieve anything. You will not go far. There's nothing someone that a support system or someone that supports you is going to tell you that you're going to understand or know why it's like that. If you run into error, you cannot troubleshoot. You will not understand how to tweak or tweak the model blocks. You will not know how. So on-ramp course is very important. No matter how short the time is, just take an on-ramp course.
Thank you so much. An on-ramp course is try to take that. And I think the on-ramp comes in certificates as well. So while you take them, you get a certificate at the end of taking them, which are real valuable proofs to show that you actually know some stuff about it.
Most of them are just 2 hours.
Oh, and most of them are 2 hours. So you don't have to go on YouTube and have a 15-hour long or a series of playlists on how to go about learning MATLAB or whatever you want to. Thank you so much, sir, for that. So also because of your the publication you made, really solid stuff. You guys should find time to read it. We'll send it to you guys. The question I wanted to ask is, how should students use literature or existing work without feeling overwhelmed or intimidated? How should we use it so that we don't overwhelm ourselves at the same time don't feel intimidated? And the last question on this is, how much originality is realistically expected at the undergraduate final year project level? How much originality, how much of you actually did it yourself, put it together by yourself is needed. So yes, that's the question.
So publications are better, and if every publication or work has something called abstracts, I give you like a brilliant summary of the entire work. So I would always advise you the abstracts. Because this work addresses what I am interested in. So I don't waste your time reading 6-7 pages of the whole publication and then realize that it's not what you want. Abstracts, it aligns everything you're going to see inside the publication. And most of them are not that makes sense. Then you want to have as many publications work that are focused on that topic you're looking at. You want to see how they approached the topic. Like you want to understand the idea for that project topic you are choosing. You want to understand how the methodology, how do they approach it? How do they get the result? How do they analyze the results? You want to understand it for as many research publications as you can. You're not just reading it for its sake. Read notes. Read and take notes. Read and take notes. By the time you are done with first 3-4, We're already seeing a pattern like these people, this is what they do. They analyze, they focus on this region, they focus on this search area, model this is what they use to model this particular behind it. This is the tool they use. And this was why they used the tool from the results. This was so it's already making the whole thing clear to you. From reading that publication, already having your own idea, already started thinking of something original. Because I've seen not one, not two, but several publications. So you should not just put out one and be like, this person does this. I'll come the next context. Give it to a paraphrasing to paraphrase it one person. That's zero originality. And those different stuff will catch you. So if you can get 100%, I don't think you can get 100% originality, but you should always use publications as a helping tool. Like, this is the giant, these are people that have done it, this is what they have done. This is how they approach it, this is the way they're thinking to approach the problem. That should be there. If not, you are just copying what you don't understand, writing what you don't know, putting a 4 shots of scope